So we're going to be drawing a bending moment diagram for this structure using these end member moments. Looking at the internal nodes, so D and E, you can see that all the end member moments at D add up to 0, since it's a nodal moment and it's in equilibrium, and the same goes for node E. ED plus EC, you add them up, give you 0. Okay, so let's draw it. I'm going to start from AD. We have the value of 100 as the moment, and it's positive. So we're going to assume this to be with the clockwise rotation. So if the end member moment at AD rotates clockwise, we know it also has an equal and opposite nodal moment. So anti-clockwise. And this is going to help us, the nodal moment, to determine which side, so to the left or to the right, we're going to be drawing our bending moment diagram for member AD. So we said the nodal moment is to the left. And if you zoom in, you can see that this side, to the right, is going to be under tension, and the side to the left under compression. And we draw bending moment diagrams on the side which is under tension. So this way. The value was 100. And now AD. DA. Once again, positive rotation for the end member moment at DA. Positive, so clockwise. And the nodal moment, equal and opposite. Looking at the beam, at the member, you can see this side is going to be under tension. So we draw it on this side, and this one's under compression. So the value was 400. And this is so far member AD. Looking now at member DB. The value of moment at DB is 100, clockwise, positive rotation for the end member moment. So the equal and opposite nodal moment shows that this side is under tension. So we're going to be drawing to the left the value of moment. So that was 100. And now what about from B to D? We don't have any value of moment because at B we have a pinned end, and moments at pinned ends equal 0. So just a straight line joining member DB on the diagram. Okay, now for DE we have minus sign in front. So this means anti-clockwise rotation for the end member moment at DE. So anti-clockwise would look like this. And the equal and opposite nodal moment, you can see that this side is going to be the one under tension and this one under compression because it gets kind of pulled in. So drawing it upwards, 500. Okay, now for ED, positive rotation, clockwise. So if it's clockwise at ED, it looks like this. Equal and opposite nodal moment. You can see that this side is going to be under tension and this one under compression. So once again, we draw it on this side. And it was 200. Okay. But we can't just join these two lines up because what's going on in our structure, we have a uniformly distributed load acting on member DE. So to take that into account, we're going to have to do WL squared over 8 to find the maximum moment at this point. If you wanted to find end member moment, so at D or E, you would have done WL squared over 12. But we wanted the maximum moment at midspan. WL squared over 8 is going to be 500 times by the length let's say 1, say this length is 1, squared over 8, so 500 divided by 8 is 62.5. So the maximum value of moment at midspan is 62.5. Let me write this here. Okay, so we say we can't join these up, but we can find the value of moment that would have been acting at midspan by finding basically the midpoint of these. So 500 plus 200 is 700, and 700 over 2, because we're looking at midspan, tells us that here we would have had 350. And from this value of 350 moment at midspan, we have to subtract the value of the UDL we have found here. So 350 minus 62.5 equals 287.5. So we're still in the positive region. So here we have 287.5. If this value of moment from the UDL was much larger than the value of 350 we would have found here, so if it was larger than 350, we would have had to subtract a larger value. So say it was like 500. 350 minus 500 would have been minus 150. And if it's minus, we would have had to carry down our bending moment diagram to this point. So somewhere below the member DE, and write 150 and join up to this point. So this would have been our bending moment diagram if this was a larger value. Okay, now for last part is EC. Minus 200, so anti-clockwise rotation for the end member moment. So if EC end member moment is anti-clockwise, the nodal moment is clockwise. And you can see that this, you can't see, this side of the member is going to be under tension. So we're drawing on this side. The value was 200, yeah. And for CE, we have minus 100, so anti-clockwise, and member moment for CE. So clockwise for the nodal moment, and this nodal moment determines that, this side is going to be under tension, because you can imagine it kind of being taken this way. And if this side is under tension, the moment is drawn to the left, value 200, and just join them up. Okay, that's it.